And over to you.
Thank you very much. I've been working with ETL systems for the last 3 to 4 years, and 1 to 2 years with multimedia streaming processing pipelines under membrane framework banner. Today, I would like to share what I've learned throughout that time. During that tenure, I spent about a year working with Oban and about a year working with Broadway specifically. To make our life easier, I have spread QR codes to the relevant information throughout the slide deck. They will be located in bottom right corners of the slides. If you want to learn more about particular subject than I will be talking about, please scan them. They contain documentations, comparisons, and other information like that. Before we start, who used Oban? Please raise your hand. Great. Who used Broadway? Who have to decide which one to use? Oh. Okay. So you might be asking why. Those two libraries seem to be two different beings. That being said, I got a lot of messages on #Oban Slack channel. Which one to use? I want to use Oban, I want to use Broadway, I have no idea which one to pick. I found a general confusion in that area. When I was talking to the developers, they asked me to write up what I've learned throughout these 3 to 4 years. So instead of writing a long article nobody would want to read, I created this talk. The goal of this talk is to give you tools for making more informed decisions and maybe show a little architectural hack you can use to not have to make this decision at all. The story started a long while ago, back in BlockFi times for me, when we wanted a persistent job system, and we had two options on the table, either Oban or Broadway. We've gathered a fair bit of information about the options. We already had a lot of experience with Oban. That being said, we have encountered some issues with Oban, and we chose Broadway instead. A few months later, I started to work for Jakub, and I was a person responsible for data ingestion and processing. You can think of it as a one-man department, if you will. Based on prior experience, we went with Broadway because that's what I knew. Then we hit a brick wall because it didn't fulfill our needs, and we switched to Oban instead. In general, we reach for those tools when we want something to be done, and we do not require the results immediately. It can be done asynchronously in the while. Sometimes we don't care about the results. Sometimes we want a side effect to be executed. Then we rely on the scheduler to make it happen and make sure to recover from the errors, if any occur. Before we dive into the comparison, let's ensure we are on the same page in regards to what Oban and Broadway are. Broadway is a message consumption library. The intended use was consuming stream of messages from queues like RabbitMessageQueue, Kafka, and NATS. Broadway has a very simple processing loop. During the processing, you have only 3 options. Process the message in the main loop. You can add a batching tag in the main loop. And then you can process the messages in batches based on that tag. During this whole process, messages are stored in the memory of the node that is processing them. Most of the connectors will log the message in flight. For example, if you use Amazon SQS, SQS can lock up the message for processing up to 15 minutes. After the 15 minutes, the message will reappear in the queue, and the processing will be quote-unquote failed, and it will be available for consumption again. Upon successful processing, the message will be acknowledged and removed from the queue. I would advise going for Broadway when you either can take advantage of Broadway's architecture, so process, tag, and process batch, work with file ingestion, or you do not need a precise control on the jobs, at least out of the box, because you can always add a layer on top of that if you need. Oban, on the other hand, is a job library that allows you to schedule jobs grouped in multiple queues. By default, jobs must be defined at compile time. Oban stores its data in Postgres, which does not sound like a very scalable backend for this application, but never posed an issue so far. And as you might realize, right before my slot, Mr. Parker explained that it's not that bad. I highly encourage reading A Million Jobs a Minute with Oban article to get more information. Link to that article is in the QR code. I would advise going for Oban if you are not sure what you need. It has good enough performance to satisfy most of the requirements. It is by far the easiest one to use. Having job listed in Postgres makes it very easy to control what's going on, how many jobs are done, how many jobs are in progress, how many jobs have failed, why they failed. Since it's just a Postgres record, you can even group by failure and pick up the ones that are giving you the most issues. That being said, there is Oban Pro and Oban Web, which is not very open source and not very free. I have nothing against charging for software, especially if it's valuable. Oban free version is only the tip of the iceberg. I would like to thank Mr. Park Selbert and Oban team for all the support we have received from them over the years. The Oban team has come up with a wonderful functionality package that is an incremental add-on on top of the Oban. That being said, buyers beware. It will vendor lock you. Oban comes in three varieties. Free, which is the most basic functionality. Default worker, which has only compile time job definitions. It must be defined at compile time. That's about it. And there is no view layer by default. There is the powerful. Oban Pro contains most of the fancy functionality, which will end up using 70% of the time because it's a good software. And the fancy being the Oban Web, which allows you to see job statuses, retry them remotely, manage clusters, adjust configuration, rate limits, everything you will ever want. There is a live demo available if you want to see how it works on the QR code again. I could probably spend like an hour just going through every single functionality that Oban Pro provides you. That being said, I think a few of them are worth expanding upon. First of all, autoscaling is something that sets apart Oban Pro from any library which we'll talk about. Because like with a flip of a button, you can have autoscalable system based on the trends that were observed. So if your application is seeing more load, you are getting more events, it will automatically scale that up. If there is nothing going on, it will keep it scaled down so you do not waste resources. Job encryption could be a great quality of life feature if you are dealing with sensitive data. For example, if you are consuming user-registered messages, for example, name and surname and whatever personal identifiable information, preferably would be encrypted. So having that out of the box is great. Worker hooks in combination with batch processing is a very neat way of concurrent processing a workload, and then being able to gather the processing results into one callback. Rate limiting in combination with dynamic queues can be used to enable vendor-specific rate limits. We use that in Hoku for certain vendors that had lower rate limits and whatnot. You can create a variety of dynamic queues that use same worker, but each of them has different rate limits. During my journey, I have found two use cases that seem to be most common. You either have a system that is consuming events or messages from multiple sources. So multiple sources, one thing. This is exactly what we've implemented in Hoku. We're ingesting data from variety of things and synchronizing multiple data stores. So you have one event stream, and you have to put this data in a couple of different places. So this example is very close to what we have done for BlockFi. And it shows an archetype of multi-subscriber architecture. You have a centralized point of entry, which various producers can produce events into. Like, you can think of it like having a single endpoint on a server and other services call that endpoint. You can imagine it as having a queue which multiple things publish to. Then the message processing funds out into processes that are specific for a subscriber. A real-life example would be an email consumption mechanism. You could, for example, send an email to other services, analyze them, do something with the attachments. This is a Broadway-specific solution that we came up with. To enable processing of the same messages by different processors, we can produce it many times. Broadway exposes a callback called prepare messages. It takes a list of messages and returns a list of messages. So we can technically just clone every message and slightly tweak acknowledger. Technically, it's possible. That being said, Broadway was not designed this way. It's worth to keep in mind that suddenly there is more messages in flight than producer would produce. In order to make this work, you have to change the acknowledger, as I mentioned, so it acknowledges the original message only after every single clone is acknowledged, which is quite easy to do with a long-term storage or whatever other solution. This solution unfortunately requires a more extensive knowledge of how Broadway works internally, so you can tweak it. It makes marking the initial message as done crucial to making this work. The other approach, which can be implemented with both Oban and Broadway. For Broadway, we can just create a Broadway centipede architecture, like Broadway pipeline feeding Broadway pipeline, kind of like a 70s horror movies human centipede. With Oban, you could just insert as many jobs as you need on entry point, or just use the pro feature workflows. Using workflows being obviously the easier way of doing it. The biggest benefit of this approach is how quickly and easily it can be implemented. The big drawback is that you are being held back by Oban compile time, free worker constraint, if you want to have dynamic subscribers. So if you want to add subscribers while the program is running, you have to restart it. So you have to either use Broadway or Oban Pro. You get the idea. We ended up using the first approach, implemented with Broadway and the Amnesia adapter. Amnesia adapter is not publicly available, and it's good because it's not very good. At the time, the only people authorized to make changes to the infrastructure we were working on was a dedicated team which had limited availability. So we are working with limited resources. Since we had to figure out a solution that does not require any additional services, and we cannot use Postgres because Postgres once died when we used Oban with it, we had to be a little bit creative, and Neige is built in, so we've worked what we have. So we basically use Neige as a glorified queue. We stored ID, subscriber status, the message itself, and the timestamp. Order it by timestamp, which was generated on the client side, and bang, we have a queue. We stored messages in two tables, one for messages to be processed and one for the in-flight messages. And then we've taken the most recent messages from the queue, put them in flight and execute, and put them in Broadway. And upon acknowledgement, we just deleted the message from in flight, and it worked reasonably well. Okay. At Jakub, we've created a website for showing people the properties of certain NFTs. When the users on OpenSea, they can only see NFT ID, and they have to rely on external sources to actually see their properties. The very progenitor was a game called Z.Run. You basically raise virtual NFT horses, and horses that win races are valuable, so you want to find horses that win races. And here we come. We consume the data, and we show the processed data, how many horses win the race, and the ID of the horse, and you can buy it. That's the gist of the platform. We had to gather a lot of information from, but not limited to, Ethereum blockchain, third-party APIs, files, and then mash all of that into something that is somewhat unified and useful for the users. Sometimes the changes were triggered by the log in the blockchain ledger. Sometimes it was a timed trigger, and sometimes it was just a manual trigger. Some services had a very strict requests. Spoiler alert, we got banned a few times after we were pulling too fast. And the others were just a cost optimization because talking to blockchain costs money, as it happens. The first approach. In case the trigger does not carry data, we can use Hammer or other debounce/rate limiting software to limit how many times it rings the bell, right? And if the limit is breached, just ignore this message. It must have been processed before since it broke the rate limit. So this could be a decent solution when we need to have low latency processing. An ideal solution, this would be an ideal solution for SMS processing, which I actually have done in the past, or other short messages. It have worked reasonably well until we hit the limit of rate limit constraints. So if upon receiving the message, we have to make sure that we not break those limits because we'll get banned again, and the site will stop working and users will be mad. Okay. So another approach would be to just have unique jobs, right? Sounds pretty simple. Unfortunately, we're using SQS, and at the time it didn't have, or we didn't know about the unique constraint on that particular service. I know that Rabbit message queue has that functionality, but at the time, AWS didn't have a managed Rabbit message queue, now it does. So we decided to switch entirely to Oban and don't worry about it. We ended up implementing this approach with Oban on the second iteration of the project. The first iteration was with Broadway. We leveraged dynamic queues to divide the workload into rate-limited chunks. And since the retry counts as a run in Oban, every rate limit was respected, even if it failed. The issue we faced before going with Oban Pro is the scaling. We used to run a homogeneous multi-node architecture, and we ended up configuring some nodes to be workers in certain queues, disabling some queues on particular nodes whatsoever. It's quite manageable without the Oban Pro, but it required way too much of manual management. Okay, so it turns out for a hardcore particular use case, we needed to see what is being processed at the time, and sometimes manually retry for some of the events. Particularly, the blockchain tends to hang up sometimes and just do not respond entirely. For us, it was once every day or every 2 days. In that case, we need to manually reset the nonce, which was a manual action. So we needed to basically have an ability to say, OK, every particular job of that type that failed for that reason, now go retry because we fixed the issue. And we had a lot of issues doing that with Broadway because the message would fail and enter up the queue again, and we had no control of stopping it from entering the queue again. Then we hit an issue of rate limiting. At first, we supported only z.run, so we could respect that particular rate limit. But soon we expanded our portfolio and started running into issues with various other providers. We actually ended up transitioning to Oban and paying the bill for Oban Pro and Web, and that solved a lot of issues. The Web particularly solved the issue of finding the jobs and restarting them, and the Pro helped us with rate limiting. This is more of a bonus. While I was preparing for this presentation, I talked to my ex-boss, Charlie, from Hoku. Everything was hunky-dory, and then he dropped a bomb that a while ago a new kid entered the blog called Flume. And as it happens, it would be a perfect solution for our use case because it's free and it solves our issues. Flume was built on top of a GainStage, same as Broadway. It comes with a lot of quality of life improvements, including the scheduling and rate limiting per queue, which is the important part. I think it might serve as nice alternative using Oban Pro to get rate limiting and batching. That being said, it's a bit niche piece of software, and there is not much development velocity on GitHub right now. Last commit was a year ago. Personally, I have not used that in production, and I cannot blindly recommend it, but it's worth checking out. Maybe it will solve your problem. As mentioned on the second slide, there is a pattern which you can use to avoid doing that decision at all. My current boss said that the best decision you can make is that the one that will not bind you for life, at least in software engineering. First step will be defining a worker, an abstraction over the software stack that will actually perform the work. You can think Oban Pro, Oban, Broadway, Quantum, Xjob, whatever. The next step would be defining the work to be executed. Just define a behavior that suits your business needs and that extracts your business logic to separate a module. This will also make your life much easier to test the thing. Then we need to implement a worker with whatever stack you choose. Here are the example implementations that are quite close to what we ended up using in Hoku. Please treat them more of a pseudocode. In this case, in the case of Oban, we only need to serialize and deserialize job data. If you have access to structured jobs, that's greatly trivialized. In the case of Broadway, we can either process data in handle message or group it by the worker. Grouping it by the worker has some consequences in terms of how quickly certain jobs get to be executed. In both cases, we just need to call perform work at some point. You have to be smart how you orchestrate your pipelines in Broadway or queues. If you dump everything into a single pipe, you might reach some issues with starvation of certain job types. And the very last step would be defining a facade module. For the price of Java-esque abstraction, you can free yourself from facing too many consequences of the decision we have been talking about for the last 20 minutes. This approach allows you to switch between Oban and Broadway, Xjob, Quantum, any other job scheduler very quickly and even run both of them at the same time if you really needed to. The other big benefit is being able to completely remove the orchestration layer from tests and just test if a new job has been scheduled, regardless of whether it's in Broadway or Oban. So in Hoku, we actually migrated from Broadway to Oban. The switch was surprisingly easy and took very little effort. In order to migrate work between the old worker and new worker implementations, you can just instruct the old worker to drain completely and dump the work to the new pool. When we deployed this in production, within minutes we transitioned to the new worker type. A word of caution though, once you start processing messages with Broadway and they get acknowledged, there is no going back. If you can back up the queue state before migrating, it is highly advisable. With SQS you can't, with Rabbit message queue you can do it by node. So to sum it up, a few key takeaways. Any of these tools we discussed are pretty heavy hitters. You can think that you maybe shouldn't shoot a cockroach with a bazooka. There is a variety of other solutions that are much lighter. In case of that you need maybe a job to be executed at 12 p.m. of every day, you can use Quantum, which is a much lighter solution. It can spread the workload dynamically across the nodes if you need. That being said, if you are running a heterogeneous cluster, please configure it only to run on your current node type, because then you will run into hard to debug issues. In case you need to execute a series of asynchronous tasks, but they have to be executed in series, just one after another, Xjob can give you a single queue that will execute a function after a function. And it has a very small footprint. If you just need to do something asynchronously and it's not persistent task, and just later collect the results, a built-in tasks in Elixir is enough. You don't have to add any new libraries, just use what is there. Broadway would be a great choice when you do not have to have very strong grip on messages in flight. You can imagine that your coworker asks you every now and then, has resource X, Y, and Z been updated within last 20 minutes? If you have that coworker, Broadway is not for you. With Broadway, you have to make custom solution to track that. It could be a great choice if you have to answer the question, has all the work been finished up until now? Because then you can just check how many messages are in flight. The other great use case for Broadway is ingesting files. We had a lot of success fetching and processing images and video with Broadway. I would advise trying to use Oban first if you are not sure what you want to pick. As mentioned before, low overhead, very easy to use, a lot of tooling around it. The key outstanding feature would be the duplication of jobs. If you need it, Oban is a great pick. Due to the natures of the sources used, hereby are the mandatory attributions. While I shamelessly plug with my CV, I would happily answer any questions if you have any. Okay, one more thing. If you have any questions after this talk, the rightmost link is my Slack private on Elixir Slack. Just send me a message, I will happily answer. That's all. Thank you very much.
Okay, thank you, Jakub. Do we have any questions in the room? Questions? No questions. Okay, I think we had a question in Huva.
Okay.
It's you already spoke about RabbitMQ a bit, but the question exactly states, what about RabbitMQ?
I have very bad luck with RabbitMQ under heavy load. So I would just rather use something else. It's just a personal preference.
How many nodes were you running?
13.
Yeah.
And about 1 million messages every minute.
Okay.
So that wasn't a very good experience. In that case, I would use nuts. Nuts, in my experience, performs quite well under these loads.
Okay, cool. And no more questions. We are also running. Oh, okay. One question, and we have 1 minute left.
Yeah. How do you emulate such a load? Now you mentioned so many
Gatling.
nodes. Sorry?
Gatling on multiple servers.
Okay.
You can ramp it up even. Gatling is not very good for if you have more than one node. We are just doing it very dumb way. We're just spawning multiple VPSs in the same network and arrow up and hit enter to start the load from multiple nodes.
Okay, and then it starts boiling.
What?
And then it starts boiling.
Yeah, exactly. That particular thing was when we were testing an SMS service.
Okay.
So yeah, the requirement was to handle 10 million messages every minute. So we needed to somehow test it.
Okay. Thank you.
Okay, thank you. We are out of time. Let's give a warm round of applause to Jakub.